Hey everyone, I'm Jamie, and I'm really excited to be here today to talk to you about Neon with GraphQL. I want to show you something that we've been working on for a while at GraphBase to integrate Postgres and generate instant GraphQL APIs. You can learn more about me and GraphQL at my website, and you can also follow me on Twitter or X or whatever it's called now. My handle is just Barton backwards, no trap. So the biggest problem that we have today is that we use an abundance of different tools. We use so many different tools to power our front-end web, mobile, and wherever else applications. We power these applications with all of the best of breed services. These are really cool. I use so many services to power my own website these days, whether it be a CMS or an image hosting platform for my digital assets, or whether I send notifications via email or Slack or SMS. I use a service for everything and I really like using those. However, all of those documentation styles for using them varies. All of the SDKs are different. Some are better than others. And the learning curve differs between all of these as well. So that's the problem that I think we have today. One problem at least. The next problem is actually fetching data. If I have my content and digital assets all over the place, well, that isn't really efficient to my end user. Now, I'm just talking about my own personal website that's delivering content and videos, but imagine this at a bigger scale. You're fetching content for all of your customers around the world, but depending on which services you use, that data could be in a single region, and that requires then your API to make hops around the world to fetch data wherever it needs. And that really isn't the best way to do things. Now, of course, you could pay all of these individual services money to clone and distribute and replicate your data across the world. However, they often charge you per replica, or you often end up with huge bills from dozens and dozens of services that you use. And that really isn't great. It's going to cost you so much money, right? So what I want to talk to you about, what we're doing at GraphBase to improve this, is by using our caching service. So we're able to write connectors for all of your different data sources, and then you're able to invoke those. And obviously Postgres and Neon is one of those that I want to show you today. We can take that data, create an instant GraphQL API, and then deploy that API to the edge. And then when users query data from that, they fetch that data from the cache instead of going directly to the database. That means you don't need to replicate all of your data and pay all of those costs. So let's dive in a little bit further and figure out how we actually connect all of our different data sources. So here we have some data connectors inside of GraphBase. We have GraphQL, MongoDB, Open API. We can take any Open API specification and automatically generate a GraphQL API. But I want to talk to you today about Neon and Postgres. We have a Postgres adapter that you can use, and then you can insert your URL to your Neon database. Then we can do some magic and introspect what your database looks like, and then we can generate all of the GraphQL queries and mutations to interface with your database. So once you've connected, the next step is to deploy. And as we mentioned before, the edge is really important. We want to make this data available all around the world. So we then need to deploy that. And we've made it really easy with our CLI to run npx graphbase deploy. Once you've deployed this, it is then available to all of your users to query. And we do this using Rust. The whole thing is built with Rust. We then package that up, run that with WebAssembly, and deploy that to the edge with the Cloudflare network. Once we have the API deployed, then we need to query it. So here I have my Neon dashboard, and I have a single table here called users. It has the column ID, name, and email. Then we can see we have a query to fetch all of my users. And you as a user had nothing to do. All you needed to do was connect using the GraphBase Neon or Postgres connector, and we would generate this API for you. So here we can do things like filter, paginate, and even order and sort data from Neon using this instant API that we generated using your connection string. Then we have a mutation, and we don't just have the mutation to create, but we also have mutations to update and delete, and we have the batch variants of those as well. So you can insert, update, and delete many things at once, which I think is really cool. Now, this all sounds and looks cool, but I think we should dive into a demo and have a look and see how all of this works. So here inside of my project, I have a single GraphBase folder. This folder can exist inside of your existing mobile or front-end repo. This folder can contain configuration for your backend. And here we use the connector for Postgres, and we've given this a name of neon. We've then passed the environment variable neon URL, and we have an env file locally with that value for the connection string there. Then all we need to do to generate this API is to invoke g.dataSource and pass that connector. This then adds neon as a data source to our GraphQL API. Then we export a single configuration object with our schema, and then we have some defined caching rules to cache all of our queries for 120 seconds. We can also configure things like stale while revalidate, so we can return stale responses while refetching in the background, which is really cool. You can configure these caching rules on a per type basis, so you could choose to cache your users, but if you had another table for posts, you could cache those for less or longer, depending on your use case requirements. With this, we have a GraphQL API automatically generated for us. But what if we want to generate a field or resolve a field using code for a field that doesn't exist in our database? Well, the way that we can do it is by using some code that looks like this. Inside of my configuration for GraphBase, I can say that I want to extend my database user, then we can provide the field gravatar, and then we can specify some input arguments. We can then declare, using the SDK, what this field will return. Here we specified that this field will return a URL, and the resolver is gravatar. Now if we look inside of the folder resolvers, we have this file gravatar. This has some default options, and then we're able to abstract the email from the current request, which is the user, and then we're able to run some code to return that gravatar URL. And gravatar is a field that doesn't exist in the database, there is no column for that, but GraphBase will run this code at the edge and resolve that field using the value from the database. So to run this, we can run this locally by running npx graphbase dev. Once this is running, we can head on over to port 4000. This is Pathfinder that's running locally with that GraphQL API that was generated for Neon. Here we have queries to fetch a user by an ID, or we have a query to fetch all of our users in a collection. This collection query has arguments to filter and paginate and order data from your Neon database. We can then loop through all of our different nodes to return the fields that we like. So here we can see that we're returning the ID, name and email, and then this gravatar field. Now gravatar isn't a field in our database, it's actually a remote resolver, or what we call edge resolvers. If I execute this, we can see the data on the right is returned to us. That took a few seconds to return the response, and if I open up the history pane here and scroll to the bottom, we can see that took about 3 seconds by the time it went to the database and returned that data. Now this was a cold boot, it was the first time I ran it, but if I run it again, we can now see that response was returned to us within 3 milliseconds. And that is because of that GraphQL edge caching that we've configured. Now if we switch on over to creating a new user, here I'm going to go ahead and create a new user inside of our database. And here I'll just insert a new user and we'll run that mutation. That then inserts that data inside of our Neon database. So if we go back to Neon and we refresh, we should now see that we have that new user inside of our table user. So that's been a quick look at how we can generate GraphQL APIs for our Neon database. We are really excited for our users to try this out, so if this looks interesting, please join us on Discord and head on over to graphbase.com where you can learn about how you can use this connector. We'd love to hear all of your feedback, so please do let us know, and I hope everyone has a great day here at Neon Developer Days.